Hello everyone, welcome to the Mathematics in my channel. Here another interesting integral from 0 to infinity dx over x to the 5th power plus x to the 4th power plus x to the cube plus x square plus x plus 1. Well, in this video I'm going to solve this question by using two methods. The first I'm going to solve this one by using the simple things substitution method. So even the college student can solve this one by using first method, and my second method a little bit complex by using a Digamma function. Okay, let's see first method. So first I'm going to take a substitution. U is equal to 1 over x, then du is equal to minus 1 over x square dx. Then if you isolate the dx, we know dx is equal to minus du over u square. Okay, now we can plug in. So our integral, if you take I, now I is equal to, we know after taking substitution we should change the boundaries. Infinity to 0. Then dx, we know dx is equal to minus du over u square. Then here x to the 5th power, so 1 over u to the 5th power plus 1 over u to the 4th power plus 1 over u cube plus 1 over u square plus 1 over u plus 1. Okay, then we can simplify here 0 to infinity, here minus sign, so we can interchange here 0 to infinity. When we change the limit, this minus sign get cancelled, and also we know definite integral independent of the variable, so instead of u we can use any variable, so we can use x. And at the same time, if we simplify here, common denominator we know u to the 5th power, and here u square get cancelled, so we have in the numerator x cube, so x cube over, now here we have again here x to the 5th power, so x to the 5th power plus x to the 4th power plus x cube plus x square plus x plus 1, and here we have dx. Okay, then we have common denominator, and we know this integral is also equal to I. Then let's take sum of these integrals, so we have 2 times I, so 2 times I is equal to, we know if we take the common denominator, we have this one, same one, so in the numerator we have x cube plus 1, so here x cube plus 1, and also this one we can write x cube plus 1 x square plus x plus 1, and here dx. Now we know x cube plus 1 get cancelled. Then we have 2 times I is equal to integral from 0 to infinity, here dx over, now denominator I'm going to take as a perfect square, so we have x plus 1 half perfect square plus 1 minus 1 over 4. So if we simplify here 0 to infinity dx over, now 1 minus 1 over 4 we know 3 over 4, 3 over 4 we can write the square root of 3 over 2 perfect square, then plus x plus 1 half perfect square. Well, now we know this integral simply arctan, so we have 2 times I is equal to here 1 over a is equal to square root of 3 over 2, so 2 over here square root of 3, and arctan of x plus 1 half over the square root of 3, and here 2 and we know the limit from 0 to infinity. Well, now these two get cancelled and I is equal to 1 over square root of 3. If we plug in infinity, arctan of infinity, 5 over 2 minus 1 over square root of 3, so 5 over 6. Then we have, if we simplify, 5 over 3 times square root of 3. Then if you multiply both numerator and denominator by square root of 3, we have square root of 3 times 5 over 9. Okay, this is the answer, and I know this one you can solve. Even college student can solve this one because it's a simple integral. But if you think a little bit advanced, maybe if you didn't see the this substitution, so then you can solve by using Digamma function. Okay, let's begin. Well, now we know our question. Now second method, our question, we know I is equal to integral from 0 to infinity dx over x to the 5th power plus x to the 4th power plus x cube plus x square plus x plus 1. Okay, now we know first this part we can write 1 minus x over 1 minus x to the 6th power, because 1 minus x get cancelled and we will have this one. Okay, then now here limit, we have 0 to infinity, so I'm going to break the limit like integral from 0 to 1 minus x over 1 minus x to the 6th power dx plus here 0 to 1, now 1 to infinity, 1 minus x over 1 minus x to the 6th power dx. Okay, then I'm going to rewrite first integral again, integral from 0 to 1 minus x over 1 minus x to the 6th power dx. And for second integral, I'm going to use a substitution. So I'm going to take x is equal to 1 over y, then we know dx is equal to minus 1 over y square dy. Then we can substitute here. Now we know we take this substitution, so definitely limit 1 to 0, and here 1 minus 1 over y over 1 minus 1 over y to the 6th power times minus 1 over y square times dy. Okay, then here rewrite this integral from 0 to 1 minus x to the 6th power dx, here plus, now here minus sign get cancelled when we change the boundaries like 0 to 1. At the same time we can simplify and we can change the variable, so we have here x cube minus x to the 4th power, same denominator 1 minus x to the 6th power, and here dx. Okay, now in both integrals we have same denominator, so we can rearrange whatever you want. So I'm going to rewrite 0 to 1, here 1 and minus x to the 4th power, so 1 minus x to the 4th power over 1 minus x to the 6th power dx plus here 0 to 1, then x cube, and we have minus x over 1 minus x to the 6th power dx. Well, nice. Now I'm going to take another substitution. X to the 6th power is equal to t, then we know 6 times x to the 5th power dx is equal to dt, so we can plug in. Okay, now we know limit also 0 to 1. Then here 1 minus x to the fourth power. So we know here if you isolate the x is equal to e to the 1 over 6. So we know t to the 4 over 6 over 1 minus t times dx is equal to dt over 6 times t to the 5 over 6. 5 over 6 plus same as here again 0 to 1. Now t to the 3 over 6 minus t to the 1 over 6 over 1 minus t, and here dt over same as 6 times t to the 5 over 6. Well, now we can simplify. So we have at the same time I'm going to change the variable again because we like to write x. So we have 1 over 6 constant, so we can take outside of the integral sign 1 over 6 0 to 1, and here we have now if we simplify here, if we take the numerator we have x to the minus 5 over 6. So x to the minus 5 over 6 minus x to the minus 1 over 6 over 1 minus x dx plus 1 over 6, and here we have x to the minus 1 over 3 minus x to the minus 2 over 3 over 1 minus x dx. Well, now I am happy because this one familiar with us. I think it's familiar with you because if you watch my videos before 4 years, so for 4 years ago, I think I solved a problem. It's related to Digamma function. Okay, I will add the link in the description and also make a card. So this one we can write 1 over 6, and this one digamma of 5 over 6 minus digamma of 1 over 6. Then here again 1 over 6. This one digamma of 1 over 3 minus digamma of 2 over 3. Okay, again this part familiar with us because we discussed about digamma function. This one okay, this one digamma of 1 minus n minus digamma of n is equal to pi times cotangent of phi n. This is reflection formula of digamma function. I proved this formula in digamma function video series, so you can watch. Okay, now our question here 1 over 6. Now this one is equal to pi times cotangent of phi over 6 plus 1 over 6 pi times cotangent of 2 pi over 3. Okay, if we simplify 1 over 6, this one square root of 3 times pi minus square root of 3 over 3 times pi. So we have now 1 over 18, and here 3 times the square root of 3, so 2 times the square root of 3 times pi. Now we have the square root of 3 times pi over 9. Okay, now we know this is the answer. Now we solve this integral by using two methods. So which method do you like for? Actually, I don't know. Thank you for watching.